Now I see a little snow flurries here coming down. Here's what we're going to do in this chapter. We're going to be looking at Newton's laws, Newton's three laws of motion, which are so important as a foundation in our course, which mainly covers mechanics. Then we're going to be dealing with units. We have the concept of force, and we have the metric system, we have the British system. So we need to talk about units. That's a little bit unfortunate, but the United States is lagging behind the world in converting to the metric system. So that makes our job a little more difficult. Then we're going to talk about two branches of engineering topics where you have Newton's laws, where the force is not, the net force is not zero, and when it is zero. When it is zero, you have the subject called statics. Things are in static equilibrium. When you have the force, net force not being zero, you have dynamics. You have some kind of motion. And for 7 years, I had the privilege of teaching statics and dynamics as engineering courses in our 2+2 program between North Carolina, the University of North Carolina at Asheville, and North Carolina State University. And we're going to take some time to talk about the method of science. And the reason why I do this is because Newton is so crucial during the period of the 16th and 17th century scientific revolution. He is like the climax. He comes at the end. He kind of like brings it to a close with his book, The Principia, that was published in the 1600s. Boy, it's a little chilly out here. And so after we do that scientific revolution because of Newton, then we're going to talk about the scientific method and what makes for good science. And then we're going to conclude with two neat problems in statics. Two statics problems at the close of our chapter. Chapter D, Newton's three laws and statics. D0, introduction. Now, Newton's three laws gives us the foundation of the discipline we call mechanics, a subtopic of physics. And mechanics has two parts, or further subdivisions: dynamics statics. Now, statics is usually taught first in an engineering school because it's the case where the forces all add up to zero. So let F be the forces, the net force on an object is equal to zero. Now you can put a vector sign over there since forces are vectors and they're going to be applied in different directions in 3 dimensions in general. Now for dynamics, we're going to be explaining in this class Newton's second law, F equals ma, where a force gives rise to an acceleration. And in the case for statics, the acceleration is zero, and you can think of like a building or say a bridge. This bridge here, dear to my heart, since it's the Walt Whitman Bridge that goes over the Delaware River. We're looking at the New Jersey side, and I grew up over in this region. So if you're coming from Philadelphia, Pennsylvania, on the bridge, you can find one of the exits here. You go left, and then south, Camden, Fairview, also called Yorkshire Village, back in the old days, way old days, 1920 or so, is where I grew up. But see, this bridge has all the forces balanced. We're not going to consider the cars, that are moving, just the bridge. And here you can pick any point. All the forces at that point are going to be summed up to zero, since there is a static equilibrium situation. So you can do that for anything. In fact, there's marvelous techniques in engineering that you could find the force in that beam, whether it's a compression or a stretch, a tension, using techniques. So in our physics course, we're going to be doing introductory things in both of these areas. And then in engineering, there's a whole course in statics and a whole course in dynamics taken after your physics course, introductory course, your mechanics course, and introductory physics. This is covered in Physics 1, which is our course, Physics 1. I had the good fortune to teach engineering, statics, and dynamics for 7 years as part of the NC State program and UNC Asheville, our 2+2 program, where you would go 2 years at UNCA and then 2 years, say, at NC State. And since then, we have added a mechatronics program, which you get a degree from both schools, and you could stay in Asheville.